Turn your key and nothing happens? Today in the garage, I'll show you how to test your Toyota starter and replace it if it's bad. If you've already confirmed your starter needs to be replaced, you can save yourself 5 minutes of diagnostic and skip ahead to the chapter mark. In this video, we're working specifically on the 2009 Lexus RX 350 with a 2GR FE engine. But the diagnostic steps will be useful for any Toyota with a weak or dead starter, and the part numbers and replacement steps will be the same for the Avalon, Camry, Highlander, RAV4, Sienna, Venza, ES300, and RX 350 models using this engine. Before we get to the vehicle, let's look at a diagram for a typical starting system on a Toyota of this era. The wiring may be laid out a little differently, but the general components listed here will give you the common places to inspect when diagnosing a starter. We'll start with the battery. The negative terminal will have a large ground cable that will be attached to the car's body, making the body and all metal components connected to it act as a path back to the negative terminal. And the positive terminal will supply voltage directly to the starter via a large diameter cable. It will also power all the other electrical systems by supplying power to the fuse block. Many components, such as the starter motor, cooling fan, and headlights, draw more electrical current than the dashboard switch or the car's ECU can handle directly. In these cases, engineers will use an electrical component called a relay. A relay uses a small electrical signal to switch on and off a much larger current, protecting the control components and preventing the risk of an electrical fire. An additional benefit of the relay is it allows high current wiring to be routed directly from the power source to the device and its relay. Rather than running a thick, heavy gauge wire all the way from the switch into the cabin, this simplifies and reduces the size of the vehicle's wiring overall. And just like relays protect the control components, there are several other safety devices that engineers will utilize to protect the car and driver, like the clutch and neutral safety switch that will make sure the car does not lurch forward if the starter motor is engaged while in gear, and a fusible link to prevent the wiring harness from melting in case of an open short somewhere in the circuit. And finally, we have the starter and solenoid. The starter is a high torque motor, and the solenoid is an electromagnetic switch and a mechanical lever that engages the starter motor with the engine's flywheel. It closes a heavy-duty electrical circuit to send battery power to the starter motor, causing it to spin and crank the engine when you turn the ignition switch. So a typical operation would look something like this. You turn the key to the start position on the ignition switch, and the circuit opens. Because the transmission is in park, the current flows through and onto the fuse, and since it's not blown, the magnet on the relay is energized. The magnetic force inside the relay pulls the contact closed and energizes the circuit for the S terminal on the solenoid. With the magnet on the solenoid energized, it opens the circuit on the starter motor and pushes the gear at the end of the starter into the flywheel to crank the engine. And when your car starts and you let the key turn back from the start to the on position, the circuits are all de-energized and the starter disengages from the flywheel. But if you're watching this video, something likely has gone wrong. So let's run through a quick diagnostic checklist. Step 1, we're going to measure the battery voltage. With a voltmeter, OBD2 scanner, or if you have a gauge on your dash, confirm the battery voltage is 12.6 volts or higher at rest. Then inspect the battery terminals are clean and tight and bottomed out on the battery posts. Step 2. Listen for symptoms. If you hear the starter spinning but not the engine turning, or if you get a single click and no crank, your starter solenoid is likely worn. If you get a rapid clicking, your battery is weak or you have a poor connection at the battery. If you hear no sound, you will want to check for a problem on the low current side. That would be the relay, the ignition, switch, fuse, and wiring. Step 3. Check for voltage at the S terminal. If you have 12 volts present when cranking, but no start, that means you likely have a bad starter. If you have no voltage at the S terminal when cranking, that means there is a problem upstream: relay, ignition, switch, fuse, or wiring. As an aside, if you have a slow, weak start after confirming all the previous steps, you will need to check for resistance in the high current cable that runs directly from the positive terminal to the starter. We will need to conduct a voltage drop test to confirm we don't lose more than half a volt when cranking. I'll link to a future video on how to do that in the description when it uploads. To get started with the disassembly, we're going to remove the plastic cowl that covers the radiator. There are 4 clips. These do not look like Toyota OEM clips, which isn't surprising at the age of this vehicle, but we'll swap those out with some correct size ones when we get to reinstall. But once it's removed, we'll have exposed 2 10mm bolts, which we're also going to need to remove to take out the airbox snorkel. And with those removed, I'll adjust our angle here slightly so we can see further into the engine bay. We're going to disconnect the 3 vacuum lines on the airbox. Now none of these are clamped, so we can just pull them out by hand. And we'll loosen these 2 10mm bolts that are holding the top of the air filter cover on. These bolts and the nuts that index with them are all captured, so you're not going to be able to remove them from the box, but they will unthread and allow the box to separate. But before we are ready to remove the top of the airbox, we'll need to remove 1 hose clamp and the electrical connector for the mass airflow sensor. And with those 4 things removed, we can slide the accordion hose back and pull the top of the airbox off and remove the filter. If you look inside the airbox, there are 3 10mm bolts holding it in place. Learn from my mistake here and loosen those bolts, but leave them threaded in, so that you can more easily remove the snorkel and the resonator tube. You can see in the video I'm going to have to fiddle with it quite a bit, because every time I pull on the tube it moves the air intake box as well. Leaving the hardware in but loose will give you the play you need, but still provide enough resistance so that you can take out the resonator tube with just firm outward pressure. Clipped into the larger snorkel itself, we have a coolant hose that connects to the radiator and an electrical connector for the vacuum switching valve. Both will need to be removed. Take care with the coolant hose. When I unclip mine, it snapped the connection right off the coolant filler neck on the radiator. I'll cover its replacement in an upcoming video, but for now it won't hinder replacing the starter, but it will prevent you from driving if you don't fix it first. With the cables free of the snorkel, you should have the slack you need to remove this vacuum switching valve attached to the air intake box. Now on the RX 350 there is a second air resonator tube that sits right under the snorkel at the front and attaches right under it at the intake box. In order to remove that, we're going to have to move back to the front of the car and disconnect the 10mm bolt holding it to the upper radiator support. Once the resonator tube is removed, you'll have the slack you need to rotate the air intake box out of the way, and then you can come back and then just slide the tube out from underneath the battery. Now with the intake removed and out of the way, we have access to diagnose our starter. We're going to start by setting our voltmeter to the DC scale and connect the black lead to the negative terminal on the battery. If you follow the positive terminal of the battery, you will see a cable connected directly to the starter. We're going to pull back the rubber boot to expose the connection on the starter and use the red lead to check for voltage. This terminal should always have battery voltage. Next, we're going to check for a proper ground. You can set your voltmeter to the ohm scale to verify continuity, but an easy way to confirm if you're unfamiliar with the voltmeter is to move that black lead over to the positive terminal and use the red lead to scratch past any corrosion that might be on the metal part of the starter housing. If you have battery voltage showing on your voltmeter, that means you have a good ground. Now let's move our black lead back over to the negative terminal on the battery and disconnect the electrical connector on the starter. This is the S terminal. With the black lead on the negative terminal of the battery and the red lead inside the electrical connector, we should see voltage when the key is turned. On some nicer voltmeters, you can enable a tone so that when you have voltage or continuity, it will tell you with a beep. But if you have a friend in the driver's seat to turn the key for you, this will make it a lot easier. Now, if your car doesn't start, even if you have power at the starter connection to the battery, a good ground on the starter housing, and voltage at the S terminal when you turn the key, your starter will need to be replaced. Now, I happen to already know that this was the case in this instance, so we didn't have to run down the entire diagnostic checklist. But once we replace the starter, I will go over where some of those other components are located. But before we do anything else with the starter, we're going to go ahead and disconnect the negative battery cable. This will prevent us from inadvertently starting any fireworks shows by disconnecting the path back to the battery while we're working. We're going to start with the 12mm nut and remove the direct power supply cable that runs to the battery. And I'm just going to thread that nut back on here so we don't lose it. There will be two 14mm bolts on either side of the head of the starter. The one on the right is a little obscured by this hose, but should be viewable when you're moving around. And it's pretty accessible with a swivel 14 and a long extension bar. The bolt on the left is actually also accessible with a stubby ratchet and a swivel. However, because of where I have the camera mounted, I'm going to use an offset wrench to sneak up on this bolt, and once it's loose, I will work it the rest of the way out by hand. And with both 14mm bolts removed, we can just shimmy the starter back and forth to get it out of place. And the replacement is as simple as putting in the new starter and replacing the two 14mm bolts and connecting the power cable from the battery and the electrical connector from the S terminal. For many Toyota starters, you can buy rebuild kits, and it's usually the preferred method for my own cars, especially since I have a pretty deep inventory of parts that have come off engine teardowns and car part outs. It gives me the flexibility to rebuild a spare before working on the car. That being said, if you're relying on a car as your only means of transportation, I would highly recommend an OEM starter from Toyota. It's one of the few parts I find that is consistently cheaper to grab from the dealership than pick up the equivalent Denso unit from an auto parts store. At the time of recording, Toyota quoted me $174 for a rebuilt starter. The parts store wanted $220 for the same Denso unit. It's also worthwhile to note the unit I just took out has a non-updated part number, which means it's lasted since 2009 and for about 200,000 miles. I'll post the part number for the Toyota starter now. Now with our replacement starter in place, I'm just using a ratcheting wrench to tighten up the bolt on the left and my swivel with the extension to tighten up the bolt on the right. And the last two things will be reconnecting the battery cable and plugging in the S terminal connector. Now with the starter replaced, we can come back to the battery, and it's a little out of frame, but I have a wire brush and I'm cleaning the inside of the battery cable, and I'm going to tap it down to make sure it's fully bottomed out on the post, and then we can tighten it down with a 10mm socket. since we had previously confirmed that our starter was bad, we didn't check this in the video. But for reference, if you turn the key and hear nothing, the first thing you want to check is your AM2 fuse. The fuse box in your engine bay is where this will be located, and on the RX 350 it's the fuse located here. If you got a single click when you turned the key but your starter did not turn, you'll want to check your relay first. And unfortunately on the RX 350 it's in a somewhat awkward spot. We're going to have to remove this reservoir and set it out of the way in order to access the relays. It's secured with two 10mm bolts, and there's an electrical connector for the level sensor on this car that'll have to be removed as well. On the underside of the lids for all the fuse and relay box locations, you should have a diagram of what fuses and relays are controlled by those systems. However, if you no longer have the relay and you aren't able to look it up immediately, a useful bit of information is to know that Toyota uses a purple colored relay for the starter. Also useful to know, most vehicle systems will use the same fuse or relay for both a critical and non-critical system. So for instance, you could swap out your starter relay for your AC relay, and it would allow you to quickly diagnose if the relay itself is your problem. The same thing can be done with fuses in a pinch. However, it's important to note, a fuse is almost never the problem. A fuse is an indication that there's a problem somewhere else. If your fuse is burned out and continues to blow every time you replace it, resist the inclination to put a larger amperage fuse and hunt down if there's an open short or a problem with that circuit. Now going back to our reassembly, I've got an overhead view of the intake box here. And we're just going to slide and rotate this until we can get it back in place. And once again, I'm working around the camera, so it's a little awkward, but we're going to move that box into a position where all three holes are visible so we can thread in our 10mm bolts by hand. In the video, I went ahead and tightened these bolts down, but I would recommend you leave them hand tight and reattach the snorkels and hoses before cranking them down with the ratchet. And again, slightly out of frame, but I'm just using a 10mm bolt to secure the front of this resonator tube. And with the resonator tube in place, we can reattach the snorkel. And I'm going to thread in the two 10mm bolts by hand before coming back with a ratchet and cinching them down. Now that the snorkel is secure, we're going to reconnect the wiring harness for the vacuum switching valve and the coolant hose. And with our snorkels and lines in place, we can secure the bottom of that air intake box and replace our filter. The top of the air intake box will also just be a reverse of the disassembly. There are two plastic cups that the top of the air box will pivot into. And once those are in place, the two 10mm bolts will line up to the holes that they correspond to, and we can tighten that back down. Now it's very important up top we don't forget to tighten down the rubber accordion tube and plug the map sensor back in. And finally, we just need to reconnect the vacuum switching valve and the vacuum hoses we took off earlier. They will have colored dots and corresponding stripes on the vacuum lines. In my case, they've been replaced probably many times at this point, so you'll have to reference the vacuum diagram guide on the bottom of the hood if you don't remember how it went back together. And with our engine pieces back on, we can replace our upper radiator cowl. Now at this point, you're going to want to test that starter thoroughly. Take your car for a drive, stop and start multiple times, make sure the starting operation is smooth and quick. If there's any hesitation or missed starts, make sure you go through that checklist one more time and eliminate any possible issues. And that's it, the starter is defeated. If you've made it this far, thanks for sticking around. If this video helped you out, consider giving a like and subscribe. Got your own tips and tricks? Leave them in the comments below. And I'll see you guys next time in the garage.